Let's continue our study of DNS. This time we're going to focus on primary and secondary zones in addition to caching only. So we'll label this subsection primary and secondary zones, which is the primary implementation or most common implementation of DNS. So the features include ability to service zones, which means you service records within those zones. When clients consult your DNS server, you are able to authoritatively speak on behalf of a zone. So 2, authoritative support for a zone. So we're going to create as our task, our first task, a zone, an internal zone named linuxcbt.internal, which currently exists and is hosted by our 75.100 system. So we'll just mimic that zone and show you the files that need to be modified. Now first and foremost, as step A, we'll modify etcname.conf to include the new zone. Then we'll create the corresponding zone files, or in this case zone file. Once done, we'll restart named and test resolution of DNS primary zone. And then the next task will be to create a slave server. A slave server is also a secondary server, and test the ability to replicate records from the primary to the secondary. So let's follow through with the steps. We'll modify etcname.conf. It currently has zones defined, and with this version of named, we have to update the appropriate view for internal versus external. So if you scroll down through the document, you'll see that there's a view defined for internal resolution in addition to localhost resolution. You want to define your zone in the internal zone if it's an internal zone that should not be shared with outside hosts. So somewhere within the internal zone, we'll need to define, or the internal view that is, we need to define our linuxcbt.internal zone. So we'll copy the definition here that's set up for the zone my.ddns.internal.zone and paste it into our documentation using Control-V. So we want to update this to reflect linuxcbt.internal as our zone. Its type, since it's a primary server, is master. Currently we'll allow no updates, but we could indicate an IP address of a secondary server. And the file will be located, instead of beneath the slaves directory as indicated by this particular entry for my.ddns internal.zone, we'll simply reference the file name as linuxcbt.internal. So let's change this from slaves followed by the directory name to linuxcbt.internal, optionally .db since it is a database. And this is all relative, if you recall, to the var named directory. So this is where primary zones are kept. Secondary zones are kept in the slaves subdirectory. So let's go ahead and nano again etcname.conf and navigate to the area where we copied the item from my DDNS, and get ready to paste in our new item. So we need to indicate the file where it's located and terminate the descriptor or the definition of the zone using a curly brace, a right curly brace, and a semicolon, which we have set up. We'll just remove the commented line and we'll be set to go. So this is the zone definition as far as named.conf is concerned for linuxcbt.internal. The fact that it's a master server, it references a database file which we've yet to create. So we'll paste this in here. We can include a comment if we'd like. Otherwise, just paste it in enough, allow for enough tabs, and here's our comment: first internal zone. Save the changes. Then we need to create a file in var named which stores the zone records. So we need to create the corresponding zone file. Now there are example files here. If we take a look at any of these files, we'll see example entries such as named.local, for example. This is a perfectly fine reverse file. It contains a pointer record. However, we need a forward instead of a reverse lookup file. For that, we can use my.internal.zone.db. So let's cat the contents of this file to see what it returns. And it is empty, no records defined. Let's cat localhost.zone, and this is appropriated. It's got an IPv6 as well as IPv4 record. So let's copy localhost.zone to linuxcbt.internal.db, as that's how it's referenced in the etcname.conf file. Then we'll modify it, and we'll need to include the appropriate records. Now, the @ wherever you see it indicated within a zone file name represents the full name of the domain. So long as it references a zone as it's described in etcname.conf and you're happy with that, no need to change it. Otherwise, you can indicate the full domain, linuxcbt.internal, for example. The name server is set to @, but again, this can be updated to be an explicit IP address of a name server or an A record of a server. We've got an A record, which is for the host, and a quad A record for IPv6 resolution. Again, for the source of authority, we can be more specific. Instead of simply indicating @, we can indicate the name of the server that will function as a source of authority. This server's name is linuxcbt-serve4.linuxcbt.internal. And the email address of the administrator of the zone is root.linuxcbt-serve4.linuxcbt.internal. Let's just ensure that this is correct. We'll bring it all on one line, and that takes care of the source of authority record. As far as the name server is concerned, again, you can indicate the name server explicitly using @, which references the domain which you will need to have an entry for, or explicitly as follows: linuxcbt-serve4 followed by the domain suffix followed by a dot to terminate the line. And if you have other name servers for this zone, go ahead and specify it. Otherwise, this will suffice. So that's a name server record. How about just general A records? Well, we can begin by creating one for linuxcbt-serve4 that's required. Internet record A, and its IP address is 192.168.75.199. Again, we have an IPv6 record. It's not necessarily a quad A record, so we'll remove it. So we've got one host defined. If we also have a mail server, let's say that the primary server is the mail server. Its type is MX, and its priority is 10, followed by a full name of linuxcbt-serve4, followed by the full name dot. And then below we define the hosts, including, and this is the first host defined, so we'll paste it, including the DNS server itself, as well as optional servers defined within linuxcbt.internal. We've been communicating thus far with linuxcbt-serve4 as well as linuxcbt-serve1, which will be sure to note, which has an IP address located at 168.75.10. These are the two systems we were working with primarily, but there's also linuxcbt media 1, which is currently a DNS server, so we'll include it as well, and its address is .100. So slowly but surely we're building a proper zone file. This zone will have a TTL of 86,400 seconds or a full day, unless each record has a TTL. To reduce the TTL to something that updates much quicker, change the global TTL, let's say to 3,600 or even 600 seconds. This will be the global TTL that applies to all of the embedded records, unless of course you indicate a distinct TTL as follows: 3,600 for the linuxcbt-serve4 record, but 600 for the remaining records. So in every DNS file you'll find a source of authority record which references the server that's responsible for the zone, followed by an email address for the responsible administrator for the zone, followed by directives regarding the serial number of the zone, the refresh rate, retry, expiry, and minimum values for retrying the zone synchronization. And it is customary to set the serial number to a value that's equivalent to the current date. So that's 2008-01-22 with a revision number of, let's say, 01. And we'll just bump this revision number up with each change. So this is a proper zone file, and we've completed as a consequence, unless we run into errors, step B, which is to create the corresponding zone file. So let's save the changes and return to the shell. Just ensure that the permissions match the other items. And notice that all the files are owned by root, at least the files, not directories, including linuxcbt.internal.db, so this is fine. Our zone's defined, and it's owned by root, and when we restart the named instance, we should be able to then perform a query of the forward lookup zone, the primary zone, linuxcbt.internal. Let's kill the server using kill all named, then a psef grep named will reveal that it's been killed. Then we'll go ahead and execute